system of nonlinear equations here for you. Now, there's common techniques when you're doing systems of equations. You can do what they call an elimination method, which usually involves multiplying one row by something else to lead to an elimination of one or more variables. In this particular case, that approach isn't really going to be that favorable. And let me just give you an example of what I'm talking about. Right here, you could solve this for y. In other words, you could subtract x cubed from this side, and then you could divide by 6x squared, and you would have y isolated. But look what would happen, how messy that would be if you substituted y back into here. It would just make this a messier circumstance. In a similar fashion, you could solve on the bottom row for x. All right, but then when you tried to substitute it back in to both of these places, or it would just be a mess. You can see that the powers would get higher, the terms would get messier. And so we need to search for another approach here, because the usual methods of substitution and elimination don't, I didn't even try, I just looked at it and I thought it would be difficult to do just plain pure substitution and or elimination. And so the way to look at this problem, it turns out, is to realize that if you thought about x plus y quantity cubed, you would definitely get an x cubed term. You would get an x squared y term, right? Again, I'm talking about the expansion x plus y quantity cubed. X cubed would be in that expansion. X squared y would be in that expansion, as would xy squared. And so we actually have to, that's an approach, and it turns out to be a correct approach. So let's take a look here. Now, the identity I'm talking about, folks, is this guy right here. Now, again, this is fairly familiar to a lot of people who've done some algebra, but a plus b quantity cubed, certainly you're going to get the b cubed and the a cubed, which you need because you have x cubed and y cubed here, right? But also this a squared b term that I'm hovering over right down here would correspond or have some correspondence with this x squared y term. In a similar fashion, this a b squared term would have correspondence with this x y squared term. Now, the crazy thing is, though, is you got a 6 right here. You have a 6 here. You have a 3 here. So it turns out the favorable expansion is to do x plus 2y quantity cubed. Okay, and that's very believable, because what happens right here, and you can follow along, but when you do the arithmetic here, you do get x cubed plus 6x squared y, all right, which are the first two terms here. And we're on our way. That's known to be equal to minus 32. So again, when you expand this out, it spits out this term and this term, but we have a concrete value. We know that's equal to negative 32, right? Now this one's a little, this part right here, the last two terms here, don't exactly look like these two terms. They're close, right? But this says 2y cubed 3xy squared equals 10. These are the same variables raised to the same powers, but different numbers. But you see, if you take a look here, what do you need to multiply this by? If you multiply this by 4, you actually get this piece right here. Again, if you multiply by 4 here, you get 8. There's your 8 right there. If you multiply by 4 right here, you get 12. There's your 12. But you would have to multiply the 10 by 4 too, which would make it 40. Now that's a lot of talking. Let's just show you what I'm talking about. All right, so this is what we just showed on the previous line. All right, it's just recopied there for you. All right, but what I just said, if you do 4 times this piece right here, you get the piece that we're interested in. All right, right above it here. Okay, that part right there, this part right here is exactly equal to this, but 4 times all of this is that, and 4 times 10 is 40. That's where the 40 comes from. Okay. Now I won't say it again. It's just a lot of talking, but I think y'all probably see it. And so what that means is x plus 2y quantity cubed is equal to negative 32 plus 40. And I hope the color coding here helped. I didn't color this because it wasn't quite right. We had to multiply by 4. Okay. What we get here is x plus 2y quantity cubed is equal to 8. but that implies that x, and you can, again, the algebra here is very straightforward, x is equal to 2 times the product 1 minus y, or the quantity 1 minus y, all right? Now, the rest of it is just substitution, all right? You can actually do substitution now. So notice what I do right here. I take the bottom equation, and I substitute x equals 2 times the quantity 1 minus y exactly in this location. This 3 becomes a 6 now. This 3 becomes a 6, all right? And then what happens, just with some fairly simple reductions, you end up with this polynomial, all right? Again, you guys can verify. But we do have a polynomial, third-degree polynomial, and we know that if it has any rational zeros, they have to be the ratio of the constant term in the numerator over the ratio of the divisors of the constant term over the divisors of the leading coefficient. And that's exactly this list, folks. This list right here, it's all possible divisors of the constant term, plus or minus, divided by all possible divisors of the leading coefficient, which is 1 and 2, right? So after a lot of checking, you will discover that -1, which is in this list, it's a rational zero. It's an integer, but it is rational technically because it's -1 over 1. And so when you substitute this in, when you get y equals -1 here just by checking the numbers in this list. All right, that took some time. I'm not trying to say it happened very fast. But again, you can put -1 in, you could substitute it right here, and you see you get the truth. This would be -2, -2 minus 3 plus 5 is equal to 0 when you substitute -1 in for a y. Now, this substitution that we just figured out earlier is used to find the x coordinate. Okay, so for -1 is a solution. We know that for a fact. Now, it's tempting. One of the temptations in math is once you have one solution, you think you're done. Okay, but the fact that y equals -1 is a solution means that y plus 1 is a factor. And let's keep moving right here. Y equals -1 is the only rational zero, which means that y plus 1 is a factor. All right. Now, I didn't know how to do long division. I mean, I know how to do it, but I didn't know how to do it inside this equation editor. And so let me come out here and show you what I did, folks. I'm kind of jumping down here, but this is called synthetic division down here. And it's a way to do long division in kind of a shortcut sort of way. You guys can view this whenever you want, but it's I didn't know how to do this other than take a picture. The equation editor was terrible. I did my best to use it, but I couldn't figure out how to use it to get this type of symbology or notation. Now, so what we discover using synthetic division is that this expression right here is equal to y plus 1 plus this quadratic piece right here. Okay, this quadratic piece, 2y squared minus 5y plus 5. So if this is going to have any more zeros, it has to happen when you set this quadratic piece equal to 0. But when you set the quadratic piece equal to 0, you do get a negative discriminant. You can confirm that, but 25 minus 40 is -15. And so you would have imaginary solutions, but you would have no more real solutions other than the 4 and the -1 that we found earlier. Hope y'all like this one because it's kind of a snake in the grass. You can't use conventional techniques to solve this, the usual elimination, substitution type. Try it. I don't think you can, but every time I tried it, it just looked horrible. So you had to relate it. You had to relate this to this expansion here, a plus b cubed, because the expanding a plus b cubed generated terms that look very similar to all of these terms up here. Okay, and the fact that you had these concrete assignments made the whole thing fly also. Okay, so let's see, I guess that's it, but for -1 is the only solution to this system. Hope you guys enjoyed that.